Okay, so now we're going to look at the application of some of the results that we've got from our derivatives of trig functions. So we've got this question where if we've got y equals sine x, we want to find f dash of 0. So what the derivative is when x equals 0, and then hence find the equation of the tangent to y equals sine x at the origin. So let's start with our function y equals sine x. And from the work that we've done previously, hopefully we understand now that the derivative dy by dx of sine x is cos x. And then we want to find when x equals 0. So finding f dash of 0 means we're going to substitute 0 in place of x. And cos of 0, hopefully we can remember from the work that we've done on graphing trig functions that the result for that is 1. If you can't remember, then make sure you substitute it into your calculator. Okay, so once we've got f dash 0, what does that mean? That means the gradient to the sine curve at the point where x equals 0, the gradient is 1. So now we want to find if the gradient of the tangent is 1 at that point, we want to find the equation of the tangent. So we're going to substitute when x equals 0, y equals sine of 0, which is 0. And we know our sine curve passes through the origin. So now let's use our point gradient formula. Y minus y1 equals m outside of x minus x1, where we're substituting in our gradient of 1 and our coordinate 0, 0. So y minus 0 equals 1 outside of x minus 0. And if we simplify that, we end up with y equals x. So hopefully this is looking a bit more familiar to you now. Let's think about graphing this. We have our sine curve that is doing this, and we want to look at the origin, what the gradient of the tangent is. And we've got this line y equals x. And this is y equals sine x. When we look at the sketch of the curve and the gradient, the sketch of the tangent, hopefully this looks familiar to us, because remember the work that we did with limits previously. We know that when we've got very small angles close to the origin, remember our limit as x is approaching 0, the limit of sine x is equal to x. So for these really small angles here, as our values for x are approaching 0, this is approaching the line y equals x for those really small angles close to the origin. So we can see that using calculus, the tangent to the curve y equals sine x is in fact this line y equals x, but hopefully it also aligns with the work that we've done previously on the limits for these really small angles as x is approaching 0.